Fantastic. Well, welcome on the opening morning of the engineering sessions. My name is Rolf Brink. I'm with Promersion, and I'm the project lead for the Immersion cooling project. Just a quick update. Many of you know me, know who I am. I've been leading the community for the last 5 years. And I am a founder and industry expert on immersion cooling at Promersion, which is an independent consultancy firm focused on innovation and collaboration. I used to be with Asperitas as CEO, after that as board member, which is a position that I recently resigned from. I'm focusing on industry collaboration to help advance the immersion cooling industry in the broadest way, supporting strategic positioning of clients and engagement with a broader ecosystem. And in that capacity, I'm doing what I do within OCP. So we've prepared for you for today, for this morning, a whole range of sessions focused on immersion. Everything that we're dealing with this morning is driven by community work, by people from the industry across a variety of companies who have contributed significantly to the advancement of immersion cooling. During this presentation, sadly, some of our workstream leads are not able to be here today because they are based in the US and they haven't been able to travel. So the materials from these workstreams will be covered by their workstream colleagues that are workstream leaders for various other pieces of work. Some of the coverage will be just highly consolidated during this morning session by Peter Cooper, who has just recently been assigned as a new co-lead for the Materials and Fluids workstream. We're going to cover some of the progression of the TCO modeling workstream. That material is going to be covered by David. He's sitting right here. IT equipment warranty, which is one of the bigger discussion points in the industry, is going to be covered by Raul, who's also sitting here. There is an OAI collaboration. OAI stands for Open Accelerator Infrastructure. That's where we're dealing with very high-powered ships. And that will be covered by Andy Young, who's also part of that work effort. And finally, the hardware management for liquid cooling workstream, which is a cross-collaboration between a multitude of projects, also crossing over with cold plate and door heat exchanger. That material will be covered by Harry Soin. And obviously, just a quick word out for those leads who can't be here. Punit Shivaprasad, Alison Boone, Eduard Reutemann, Rich Lappenbush, Michael Cordell, Chen Cheng, Jessica Goldbrandt, and Michael Jones. These people are putting up a whole lot of work to help drive the advancements of immersion cooling. There's a couple of dedicated sessions by the workstream leads who are here, representing their own workstreams. So we're going to hear from David and Raul about immersion cooling hurdles, obstacles that are in the way for immersion that we need to tackle, that we need to address and work on. Power distribution strategies for immersion cooling, and I will be, together with Peter Cooper, presenting an Intel contribution which we greenlighted at the end of last year, which is the fluid specification, very relevant for immersion cooling. It's been provided by Intel in close collaboration with the broad community, and will be presenting that on behalf of Jessica Goldbrandt from Intel. Then we're getting into signal integrity, which is something that Andy Young will be able to explain everything about. It can be a very complicated topic, but it's incredibly interesting at the same time. And finally, I will close up the morning session with the immersion requirements, which is nearing its finalization for an update on the second revision. Now, to start with, I'm just going to give a brief overview of what immersion cooling actually is. Most of you will probably be aware, but as a lot of the European audience might be new to some of the work that we do in the community, so I just want to highlight this. There's a couple of key points to immersion cooling. With liquid cooling itself is a pretty broad topic. It's the principle of using liquid to extract heat from components without using air as a medium, right? Immersion cooling is about the full submersion of IT equipment within a fluid, right? So you're literally sinking it into a fluid without any additional means to repel fluid. The fluid directly touches the electronic components. The dielectric fluid, it's a term that will come back the whole morning, is a thermally conductive fluid, but it insulates from an electrical point of view, right? A liquid directly absorbs the heat from the components of the IT equipment. Within the immersion space, there's a couple of other types that we need to highlight as well for your understanding. We have references to single-phase and two-phase fluids. Single-phase, the term phase here refers primarily to a liquid or a gas phase. A phase change refers to the change from a liquid to a gas. Like you're boiling water to steam, that is a phase change to steam. Single-phase fluids therefore consist of fluids that do not evaporate or that are not designed to evaporate at the very least. And so they're low volatile fluids with a very high evaporation point and also a very high stability. And the fluid is circulated through IT equipment. And it can be by pumps or natural convections. There are various ways out there in which this circulation is achieved. Two-phase doesn't circulate the fluid itself. It works with high volatile fluids, and that may sound scary. Basically what it means, it just has a very low boiling point. And the fluid evaporates at this lower boiling point. And by the phase change, so the conversion to gas, a lot of energy is extracted from a heat source, which facilitates a very effective cooling method. Bubbles go up and get condensed by a condenser above the fluid surface, which completes a cycle. Then there's a couple of different implementation types with these different types of immersion cooling. We have open bath. Now, an open bath can have a lid, but open baths are referred to as tank-style solutions. And the term open refers not to whether it's got a lid or not, but to an open-to-air surface. That means that there is a layer of air above the fluid, right? And typically, these type of tanks contain multiple pieces of equipment that are immersed in the same volume of fluid, right? So you have a bath and there's multiple things inside the bath sharing that body of fluid. Enclosed chassis, also referred to as clamshell, immerses IT equipment within a sealed chassis, right? So the fluid is contained within the chassis. Typically, there is a single piece of IT equipment exposed to the fluid. The fluid itself may or may not be shared with other chassis through a means of a distribution mechanism, depending on the technology type, but in principle, the design is based on insulating the chassis. Typically, those kind of solutions are rack-based, so they may look similar to an air-cooled rack with surface that you can extract. Both single and dual phase can be developed, can exist within a closed chassis implementation, right? So single and two phase is not limited to open bath. It can also be implemented in a closed chassis, right? Just to highlight the variations in the ecosystem. We do understand that, hey, we're still at the beginning of an innovation cycle within the immersion domain, and we will expect that there's going to be some hybrid forms where you may have an open bath that is based in a rack or other overlapping technologies and we're taking those into account. And just to highlight what are we talking about, what do some of these solutions look like, there's a few examples here. On the top left, you see a two-phase tank. On the bottom left as well. Right next to it, you can see some clamshell designs, some enclosed chassis designs. And then there's some single-phase open bar styles on the right side from various different vendors and technology providers. Now, why are we looking at immersion cooling? So why is nice and well? Why is it necessary? Well, first of all, there is an incredible amount of energy being used by in the data center industry, and there is a great desire to increase efficiency. There's also a desire to facilitate heat reuse, you name it. About 1.5 years ago, we had a separate workstream which was focused on, okay, let's collect all this material on the deck. This is one of the slides that came out of the deck. So I'm not going to go through the entire pitch deck, but the pitch deck is available for download through the Immersion wiki. Basically what we're looking at with immersion technology, you can work typically on elevated temperatures, which means that you don't need mechanical chillers with compression cooling. You can, simply because you can work with a primary water circuit to distribute heat throughout the facility, you don't need to move air around, which is a lot more efficient. Higher grade, elevated temperature for IT operation also allows you to reject heat at a higher temperature, which means, hey, that might be valuable for reuse. So what you have as a waste product in a data center has a much greater potential for reuse capabilities, right? There's a lot more. Hey, a lot of people tend to think, well, but immersion is so expensive. How is it ever going to be a good business case? Because my rack is only a couple $100, and I need to replace it with a tank for so many $1,000. In reality, CAPEX and OPEX are typically a lot lower compared to an air cooling infrastructure. However, when you're talking about a brownfield installation, as in expanding a current facility, for a pilot purposes, that's where some additional costs may be required. But these are things that the pitch deck deals with and explains as well, right? So we can get in depth with that. But it takes a lot to make such a radical change in the industry, right? So to make this technology available worldwide, there's a lot that needs to be done. And data center experts, data center operators are experts in availability and uptime. And the last thing that they will ever do is take a risk based on conflicting information and incredible marketing pitches by innovators, right? To facilitate such a change, there is a much larger collaboration needed where we can provide an unbiased view on the technology, on innovation, on the merits, on the value, but also on some of the challenges and the downsides. And this information must be created, and it can only be created with a large group of participants in an industry platform. OCP has become that central place and that platform. This is the place where we do knowledge sharing, where we share best practices, where we define white papers, where we create white papers outlining these best practices based on the experiences of all the competitors out there who are openly trying to help with the advancement of something that is so incredibly efficient that it's crazy that we haven't ever started doing this 20 years ago, right? We have one of the largest communities, we have the largest community within Open Compute. And as far as I'm aware, it's also one of the largest, most active communities in the industry currently focusing on such an innovation. And that can be quickly seen if you look at the current structure of the Immersion project. The Immersion project exists within the Cooling Environments project. So we have a mother project which is called Cooling Environment, and that contains cold plate, immersion, door heat exchanger, heat reuse, and advanced cooling facilities. The names of all the leads are on there. To save time, I'm not going to call everyone out. But we are within the project with the Immersion, and Immersion technically is a sub-project. But Immersion itself is bigger than any other project. Currently, we have about 350 subscribers to the Immersion community. And a lot of those are very active members participating in a variety of work streams. So all the work streams will be touched upon today in different formats, but one of them I just want to highlight here because it's a strategic one. One of these work streams, I already mentioned it, is the hurdles work stream. And this, for us, is probably the most important one. Why? Because we're spending a lot of effort on creating materials, creating references, creating best practices and white papers, and we're getting information out there which used to be covered by top confidentiality within various corporates or startups. It doesn't help with a transition if information is hidden. So what we're trying to do is identify, hey, why should you not do immersion? Why is immersion a terrible idea? And that's what we want to know about. Because that pinpoints some of the challenges that the industry is facing and helps us focus on what we need to work on as an industry. And that is exactly what the hurdles team is doing. It's actively identifying hurdles and anything that is getting in the way. This work stream is focusing on creating some base collateral to identify and expand on, to build a bit of a case of what that hurdle actually means and what is needed to resolve it. And that results in the creation of new work streams. When a base collateral is there, that is used as an incubation material for the creation of a new work stream where we can engage with the community. Hey, is this something that we want to work on, that somebody wants to participate in? Where we can do a call for leadership for a new work effort associated with immersion. And we publish this on the public calendar and get the involvement from the industry. And that work stream is then officially focused on resolving a very specific hurdle or addressing a very specific topic in the immersion project. A couple of examples, very recent examples, is in December we decided to, or last November, we decided to kick off 3 new work streams at the same time, which is a big deal. Within 1 month, we found the workstream leads, we found the participants. I think the average workstream now has about between 15 and 30 participants to work on the topics TCO modeling for immersion, to highlight, hey, how can we share the knowledge about how you can build a TCO model based on immersion and create a comparison with air that actually makes sense, that doesn't use the bias information from vendors, but has a real clean view on what the situation really is. Warranty guidelines for immersed IT. Sadly, today, the reality still is, for many newcomers in immersion who want to adopt immersion, and as soon as you immerse an off-the-shelf piece of IT equipment, you lose warranty. Well, that's no way to scale a business. So that is something that usually gets resolved, but it takes a lot of time and effort to get through that process, to work with the vendors, and that is something that needs to be resolved industry-wide. So there is a workstream called Warranty Guidelines for Immersed IT, which is really aimed at identifying how you can facilitate warranty. That's led by Supermicro and Seagate. TCO modeling by Intel and Alcatel. Then finally, signal integrity. Fascinating concept. That the sheer idea of immersing something in a dielectric fluid, that the dielectric properties of the fluid itself can actually cause a reduction or a reduction in the reliability of signals moving between 2 chips. at certain high speeds. That is a concept that is fairly complicated, and Andy is going to be shedding some light on that topic later on this morning. Fascinating stuff, but those kind of those are examples of workstreams that we've kicked off. Now, all this information about which workstreams are doing what, which workstreams can you find on within the Immersion community, how you can help and join and participate in these, can be found on the wiki page. So recently, we've spent a lot of work on updating the wiki page. The link can be found here. It lists all the contributions, all the current work in progress. And honestly, we need your help. We really do. This transforming an entire industry is so much work, and it requires so much involvement and expertise. It is not hypothetical that immersion is going to be a very important technology for the industry. I'm never going to say that the whole industry will be dedicated to immersion, no. But immersion plays a very important role for the sustainability of data centers in the future. We need your help, we need your participation, and the only thing you need to do to actually participate is to join calls. We have these conference calls, which are recorded every month. There is a detailed call schedule also on the wiki page. Every workstream has its public calls. Some workstreams are invitation only, but currently we only have one of those, and that relates to the OAI collaboration. Again, more on that later, but it's just dialing in. If you're scared to speak up, feel free to listen in to these calls for the first couple of calls, but we really value your input. Your input can be a question that you want to ask, which you may feel is a stupid question. Let me tell you this, there is no such thing as stupid questions. We need the questions to be asked because it helps us define what are the questions that are out there. If you have a vision or a view that you feel that we need to take into account, please share, because that is what the workstream leads and what the project leads need to define the strategy going forward with the community. Now, we have a recurring monthly community call where we are sharing a lot of information about what's going on in the project, similar to today, but then even more compact. And we're just about to restructure it because of the sheer amount of work that we're doing. We're running out of time on the monthly call. So we're separating some topics. We'll be alternating with the monthly content. And it basically just looks conceptually like this. This is not a final schedule. We're still figuring this out. We don't have the content filled yet, but the intention is to alternate, to do a bi-monthly, from now on, update of the community content, where all the workstreams provide their information and their progress. And we also want to do the bi-monthly, on the other months, of course, content that is external to the workstreams itself, right? Where we can get some relevant material in from industry developments, things that may not necessarily have happened within OCP, but has the involvement of an OCP member or is otherwise relevant for the industry in combination with Immersion. So we're still figuring this out. We're trying to figure out how we're going to do this exactly, but hopefully, if all goes well, the next month's community call will be focused on external content. For those of you who like to access directly from this presentation some of these materials, feel free to scan the QR code. But please know you can find the same links on the wiki page. And this presentation will be available for download immediately after the summit. Now, I would like to invite Peter Cooper to share some of the progress that the Materials and Fluids workstream has made over the past half year. Feel free to come up on stage. And Peter will also be representing Punit Prasad from Shell, who is a co-lead together with Peter. Peter, please go ahead.
Thanks, Rolf. So yeah, I'd like to just give a few kind of updates on the work that's been done over the last year, and then also a bit of outlook on some of the topics that we're focused on. But before I dive into that, one really important thing I want to mention here, which I think is a big improvement, is the name change of this workstream. So this workstream actually started out as a workstream which had a very specific scope on material compatibility. So it was called the Material Compatibility Workstream. And initially we had a lot of participation from fluid vendors especially. Over time, that's grown significantly from maybe 8 active participants on the calls to over 30, 40 even in some of the recent calls. And the name change from material compatibility to fluids and materials really reflects the new makeup of that workstream. So now we not only have the fluid vendors, but we've also got cable vendors, silicon manufacturers. It's really a diverse group that are all focused on that interaction between the fluid and materials, right, which really does go beyond simple material compatibility. So just briefly going through some of the achievements over the last year. So in 2022, we published the Material Compatibility and Immersion Cooling document that Rolf just mentioned. So this is a really big step forward for the industry. Basically what it does, it explains the concept of material compatibility interactions, potential interactions between fluid and materials, and also provides, really importantly, a common test method that people can use if they do want to look at how does my fluid interact with the material, or vice versa, how does my material interact with fluids. And it also provides a matrix of shared data that you can also access and review if you're interested in seeing compatibility of various fluids with various materials. QR code is on the slide here if you're interested in that. The second piece of work was base specification for immersion fluids. So this was the document that was promoted by Intel. The fluids and material group had a strong input into that, obviously because of the the expertise for coming from the fluid vendors, especially there. So again, the QR code is there to access, and we'll have a later session to go into detail about that if you're interested in that. Looking ahead at the work that we're going to be doing for the rest of the year and beyond, I really just want to mention some of the topics that are being discussed now, just in case anyone's interested, if you see that they're relevant to you. I really encourage you to join. Again, you can access the wiki or the QR codes to get involved and sign up to the mailing list. So yeah, just a really brief review of some of those topics. So continuing on from the document we published last year on material compatibility, we recognize it's the first step, it's not the end goal, right? We had some recent discussions about limitations of that approach so far. So continuation of ongoing work on individual component level material compatibility testing, that's a really important topic going forward. Related to that is the second one, where we're going to bring in the expertise of the cable manufacturers who are actively participating now, sharing their experience and expertise in material compatibility, how do they test, and that again relates to the signal integrity topic that Andy will be talking about later in more detail. Again, a third related point is optic fiber cables. How are those tested for material compatibility? I think we're going to really start to get into more relevant details there. Changing track slightly, so far we've been focused on individual material and component level compatibility, but one really important topic for a lot of the server vendors, OEMs, ODMs, is how do I test a whole server or a whole system in immersion, right? So currently there's no established test method. I think that's going to be really important. Next, there's a couple of specific property-related, fluid property-related topics. So auto ignition temperature, has been a really important topic, and how relevant some of the industry standards that are being applied to immersion are to auto ignition temperature. Then we've got the acidity limits for some of the fluids. There's been a lot of great input recently on that topic. Harmonization with some of those standards, industry standards, IEC and UL, we really need to feed into those efforts. Again, there's a parallel work stream to that. Developing a cleaning procedure for servers when swapping between, for example, different fluids with different chemistries. How should we do that? What are the things to take into account, right? We need to start leading and providing some guidance there. And then finally, the accelerated aging testing of immersion fluids. Can we all come up with a common standard or test method for testing the oxidation and aging of immersion fluids? So that's it. Now I'd like to hand over to David to cover the TCO modeling workstream. Thanks.
Hello. I will present the TCO modeling, which is led by Alison Bowen and Eddie Reutemann from Intel. And it is very important topic. As you know, it's come from the immersion cooling hurdles. And it is important to the customer evaluate what benefits he will get from this shifting. And it is too complicated for enterprise or to the company to understand the benefits, because it's really comprehensive. It is shifting from air to immersion, but it's not about the air cooling. It is about energy system. It's about impact on the energy grid. It's about the possibility to make heat reuse, and it have involved a lot of stuff in these calculations, and it can take for the customer 5 years to evaluate that. So thanks to the Rolf, which contribute his 5-7 years experience in that calculation, 10-time revision of that calculator. But now, if you are the customer, if you are a producer and want to get that access to that tool, please join to that call, download that tool, have a look for the benefits where we compare apple to apples, and make your contribution. Say us what is we missed, how we can improve, and this is the real collaboration. So now anyone can join there, download that tool, improve that, use that, and this is the main idea of that workstream.
Thank you. We got Raul Alvarez
Thank you, David.
speak on behalf of Rich Lappenbush and Michael Cordell.
Correct. So, the IT warranty working group workstream here is actually taking from Peter's new leadership position on the immersion fluid specification and the materials, and tries to find, let's say, this engagement with the industry on existing, let's say, warranties for air cooling in that sense. So we are trying to come up, or the guys are trying to come up with a model and with an engagement in the industry just to set this straight. So in that sense, they are trying to bring up, let's say, as you can see there, a full, let's say, industry collaboration between IT equipment manufacturers and fluid manufacturers and system manufacturers. In here, they are getting that top 10 by equipment or by component engagement just to understand and create a taxonomy. And in that sense, let's say, be able to categorize and specify every every system by let's say, by a taxonomy of equipment ranked by heat generation. So please join that call and support that community joining that workstream. Thank you so much.
All right, thank you, Raul. Just for information, this workstream has just gotten off the ground, right? So this is just all the framework stuff. So I'd like to ask on stage Andy Young, who will be speaking on behalf of Jessica Goldbrandt and Cheng Chen, and myself, actually.
Everybody, yeah. Hi, everyone. So the OAI collaboration group is a closed group, but open to participation. You just have to volunteer. And the reason that it is closed is that some proprietary information is being shared on an exciting platform that we believe we can cool through immersion cooling methods. We're looking at single-phase and two-phase methods. And it's part of a life cycle of the cooling solutions which are being proposed and applied to this platform. It's a GPU-based, multiple GPU-based hardware platform, which we'll see some pictures of in a moment. But on this slide, you can see the evolution of its architecture and the evolution of the data rates of communication and the kind of power that's been evolved by the GPU components. So the data rates are increasing up to 112G. We're changing up to PAM4. And the power that's being cooled is increasing from 450 watts, more than doubling up to a kilowatt. So this is a challenging project. And the great thing is, though, is that there's a belief in the community of immersion that we can cool this with immersion. And there's obviously a range of challenges that we need to face for this particular server, but they're not ones we haven't faced before. And in the community, there's a great deal of experience in tackling challenges like this. So the images on the right show you the overall chassis layout, which is a 2x4 array of GPUs. The chassis you see here is quite bare, but there is other equipment in the chassis which we have to work around, be it via routing cables or connectors, or perhaps even some hardware for cooling like pipes and pumps, etc., if they exist inside the chassis. And in the lower image, you can see the actual heat generating component. And the yellow part of this is where the 1 kilowatt of heat has been evolved from. This is a CAD model. And the phase of work that we're in the group is to do simulation works. So we're busy working together to define what the boundary conditions and the temperature requirements of these components are. And we're looking for the community to also get into what materials we can apply from the range of materials which have been proven to be compatible with fluids in the other work streams. And within the signal integrity work stream, we're tackling the issues with the high data rates of communication. So this is in its initial phases. It's defined in terms of the problem. We've extended the scope of the problem definition to include not only the thermal and signal integrity performance, but also the energy efficiency performance and how this technology is cooled and integrates to the heat rejection infrastructure of the data center. So it's not just a technology project focused on a particular server, but it's how we can apply immersion to that and how it can exist and perform well in the wider environment of the data center and be energy efficient too. So it aligns with all the axes that Rolf told us about around PUE, energy efficiency, TCO, but right now we're focusing on the challenge of thermal and data communication rates. So more to tell on this as we get some results and some technology applied to that. Perhaps we'll see something in San Jose. Thanks, Rolf. Thank you.
Right, thank you, Andy. And as you can see, a lot of that work is focused on the harmonization between all the various workstreams that we have, and that also is a nice bridge to the next one. Harry Soin will be presenting on behalf of Mick Jones, who is who's running the hardware management for liquid cooling. which is a cross-project collaboration. So this goes beyond immersion and includes facilities
Right.
and everything else.
Thanks,
Go ahead.
Ralph. Yes, as Ralph pointed out, this work stream, extends across multiple facets, and what Mick and the team is trying to do is bring it all together, and it's a unified schema. That's what they're working towards, for the management of the OCP, the entire OCP liquid cooling equipment. That encompasses from CDUs, immersion tank, enclosures, cold plates, the rear door, all the things you can imagine. So, idea is to bring it up all together using Redfish. I mean, that is taking control these days, and that's what we have used in ORV3 as well for communication purposes. And the objective is, when it's done, to create a mock-up, a few examples as to what output you are expecting from it, so that people can really visualize the whole communication aspect of it, right? And how the interfaces, the management systems, and the control of this. And you will see, at the end of the day, they will create some, interoperable profiles which user will be able to use and apply, to take it further. So moving on. So what have we done so far? The version 0.95 was released. It's work in progress. The schema was already released for people to look at it, and it's accessible at the link which you're seeing it on your screen. The version 1.0 will be the next release essentially that would cover 80% coverage of all the resources and all the relationships. So that will be a big deal when that's out. And V1 Plus will roll out eventually after that to cover the inadequacies or the other gaps that are missing. And the sustaining model is expected in 6 to 9 months after that, after the version 2.0. So 95% coverage of the items, will be pushed out. So essentially, this will cover the whole broad spectrum, covering the entire immersion model, CDUs, PDUs, power, everything else using Redfish. So that's it for Mitch. Thank you.
So thank you, guys. And this is also an effort to show how much of this effort to bring immersion into the industry is a matter of teamwork, right? The community consists of members, of participants, and workstream leads, and the workstream leads are all volunteers, myself included as project lead, right? It's a team effort. We've got a large leadership team within Immersion that are working very hard to help the industry achieve a lot of goals. And one of the questions I get a lot is, okay, so, hey, how do I contribute? How do I help? How can I participate? Well, I already showed you the call schedule. It's really as simple as dialing in. You don't need to register for dialing in. Anyone in the world can just dial into these calls, join the calls, just follow the links, and you'll get into the call and you're part of that public forum instantly, right? But how do you know who makes the decision on what is going to happen? Well, here's the fun thing. It's you, not me. I don't make decisions which direction we're going to take. Because everything that we come up with is community driven. If I come up with an idea, hey, I want to put an elephant on the North Pole because, hey, it's in line with liquid cooling, nobody in the community is going to work with me on that, right? If there is something that the community needs to do business in this ecosystem, it's our job as project and workstream leads to facilitate you, to facilitate the creation of new work streams. And we will. We will get volunteers. We had 2 leadership openings in the work streams. We had 11 very highly qualified applications within 1 week for 2 volunteer leadership roles in the immersion community. So we had to pick, we had to choose, and we actually had to disappoint 9 people for that. Highly qualified people that I'm proud to say they are contributors in the community. So, okay, I dial in, then what? Well, I said before, there's no such thing as stupid questions. Ask any question that you may be in your head, that you might be afraid to ask. Just ask it. Talk up. If there is a conversation and you hear something like somebody talk about signal integrity, and you don't have a clue what that means, that you just stick up your finger at. Can somebody just explain to me what signal integrity is? Because that flips everybody's mind into a mode where people realize, oh yeah, that's true. Not everybody is an expert on this topic. Yeah, we're going to have to explain every now and then what we're talking about so that everybody can come along. The only reason why you have to be a member to participate, so to participate you don't have to be a member. Obviously I would like everybody to be a member, but you only need the membership to be recognized for contributions in published documents, for example. To get your name on it, or your company's name on it, you must be a registered member, in good standing. Now, we have a strategy. It's not that we're just doing stuff because we feel like doing stuff. No, there is an underlying strategy. The goal of this project is to facilitate growth and adoption of immersion cooling. That means we're facilitating open specifications. If somebody comes up and says, I want to design something that becomes open source, or create something that is open source, or I have something that I want to contribute and make open source, that is something that we facilitate, that we can help with. We are helping the world, the industry, with creating the best practices. What is the best way of work? What does the experience tell us? We're facilitating industry standards. One of the pieces of work, like the immersion or the material compatibility work, or the immersion requirements, those are very foundational documents which are providing a foundation to standardization bodies like IEC and UL, and that really helps because there is no definition of immersion cooling in existing industry standards because it didn't exist as a product category. It does now in some, but still not all. We need to identify the risks to facilitate growth, as what you've seen with the hurdles team and why that's significant, why that is so important. And that will further be highlighted in the next presentation by David and Raul. So, I'm going to conclude this opening session for today. There is a bunch of sessions following this. They're all relevant. They're all expanding on the work done. The leaders of the respective work streams for these topics will be presenting this material. So we're going to have immersion cooling hurdles by David and Raul. They're going to be presenting together. We're going to have power distribution immersion by Harry Soin and Oriol Chavanel. We have the immersion fluid specification by myself, and I forgot to add in this slide the name Peter Cooper. Peter Cooper will be co-presenting on this. We got signal integrity, which is presented by Andy Young. And we have immersion requirements, which I will be presenting. Please join. We need your help. The European side of the community is still very slim in the active calls. I think Europe has a lot to bring to the global community, especially when it comes to sustainability, when it comes to best practices. I think Europe is setting the scene for a lot of aspects in the industry. We'd love to have you in our calls if you're not already a member, but help sharing any hurdles, any problems, any obstacles that you see. If you're a critic, please, please, please join. We like to have the criticism. And for now, I'm gonna finalize this. We do have a few more minutes for questions. If anybody wants to ask questions, and they don't need to be directed to me, they can also be directed to some of the workstream leads that are here. Thank you. Yes, please go ahead. Would you mind stepping up to the microphone there on the side so it can be recorded as well?
I'm just wondering why there are closed groups within an open environment, like for the AI.
Very good question. So yes, open compute is about making sure that the materials that are generated are open source. However, to arrive at an open source specification, you may need to do work which you want to maintain confidentiality about. Maybe you want to have a specific set of partners that you want to develop something with the aim of open sourcing. That is possible. So the Open Accelerator Initiative is one of those examples. It's working with a pre-signed contribution license agreement, and it works with an NDA in place with various participants. And that is in a different project as well. The project that we're facilitating is focused on supporting that group, but that group itself is closed. But as soon as that work is done, the specification that they have created will be public, will be in the public domain, right? So there are different ways to run these kind of projects and work streams. Most of the projects and work streams that we have within Immersion are fully community driven. That's simply the way that we prefer to work, but it's not essential. There can be close collaborations as well. We used to have one that is already finished. Right now, the Open Accelerator Initiative Support Group is invitation only, simply because it addresses some of the ongoing work within another closed group. So that's why sometimes it can be a little bit difficult, but we do make sure, when we started the collaboration, we did make sure that everybody from the community was invited, and then we made a selection of which are the material experts that can really contribute to these specific questions and apply more focus there. So we try to get as much involvement as possible with those groups as well. Does that answer your question? Thank you very much. Anyone else with a question? Okay, well then I thank you very much, and we're going to get ready for the next presentation, which will be in 5 minutes. That's the immersion cooling hurdles. Thank you. Yep.
Everything should be ready.
Well done, guys.
Thank you. There you go, right away. Lots of people